Number 6, Rolle's theorem can be applied to f on the indicated interval. Can it? If it can, find all the values c on the interval that would satisfy it. So I think we talked about it right here. In this case, f of 0 does not equal f of 3, therefore Rolle's theorem doesn't apply. But I will tell you as a hint, Rolle's theorem is not on the test tomorrow, but the MVT is. So right here, what we've got to do though is, and this is the same as the MVT, so it's worth definitely going over, and we're going to take care of this right now. Let's make sure that f of 0 equals f of 4. So f of 0 actually equals 11, and f of 4 equals 4, 16, 16 times 3 is going to be 48. 48 minus 48 is 0. Okay, it equals 11. So this is also a quadratic, so therefore it is a polynomial, and therefore it is continuous and differentiable everywhere. So therefore Rolle's theorem applies. So we are good. So what we want to do is find out where the derivative equals 0. So remember, if Rolle's theorem is just an extension of the MVT, it's really just looking for when the derivatives are 0. Okay. All right. So we want to find where does this guy equal. Now I'm about to change it up with a c. Okay, because the question is f of c equals 0. We're trying to find out excuse me, where f prime of some number equals 0. So if you left it x, it's okay. You can just set it equal to 0. But this is basically saying that c is 2. I'm sorry, 12. Wait a minute. I said the wrong thing, wrote the right thing. Okay. Or is it the other way? I don't know. But either way, c is 2, and that's the value c. All right, this one we talked about. I'm just going to go ahead and execute it. This is the restraint or the constraint where the volume has to stay 1,000 cubic centimeters. It's the surface area that can change based on that constraint. There's many different ways that you can have many different surface areas, but they all have the same volume of 1,000. We just have to figure out what is the minimum amount of aluminum that you would use, okay, or material, whatever it is. Okay, so I'm going to go ahead and just pull this off. Okay, I'm going to go ahead and solve for h, just because we've got two variables and one needs to be taken care of. So what we've got is taken care of, I mean substituted out. So we're going to use this fact right here, and that h will actually get substituted with this value here. So the surface area equals 2 pi r squared. This is the top and the bottom surfaces, okay, added together. So pi r squared is that area, two of them, okay. Then we're going to add all of the label, okay, all the wraparound, and that is what this represents here. It is the circumference times the actual length, or the height. Okay, so now we've got plus 2 pi r times 1,000 pi r squared. So we've got the pi's canceling, we've got one of those r's canceling out, and we get 2,000. So we end up with 2 pi r squared plus 2,000 over r. Okay, so now we are ready to take the derivative of the surface area. So I guess we can write it like that. And now we've got 4 pi r minus 2,000. Notice I didn't take the 2 out, by the way. That's okay. Minus 2,000 over r squared. Now we're going to set this equal to 0. Okay. And right now is actually where I could divide both of them by 2. But let's say you just missed it and you forgot. We're just going to go ahead and solve this by throwing this negative one, this negative term over to the other side. Okay. Okay. Now we're basically going to multiply both sides. But why not just multiply the r to the third power and move that 4 pi down here? Okay. So what we have is r equaling the third root of 2,000 divided by 4 pi. That can be reduced down a little bit to the third root of, what is that, 500? 500 over pi. Now, I don't know what that number is, but it's right. And if you just take this guy and throw it into here, well, throw it into here first to get the h, put the h there, and then run it through, you will find the minimum amount of material. Okay, so don't be afraid of numbers like that. It's just going to be a decimal, like just life. Life is going to be decimals. Okay. All right. So next one. We have a constraint here where we've got 180 square inches for the entirety. We have y minus 3 is going to equal this area right here times x minus 2. So I don't know why they got 2 up. Oh, here we go. I don't know why they got 2 up here and 1 down here, but that's just how it is. And we do know that y equals 180 over x. So if we did this, 180 over x minus 3, okay, that would give us our area, our picture area, okay, the shaded area, given those constraints, because the area has to be 180 square inches. Okay, so let's multiply. 180 over x times x is just 180, and then times this is going to be 360 over x minus 3x plus 6. Okay, there's really no need to put those in parentheses, so I'm going to have 186 minus 360 over x minus 3x. And that's going to equal the picture area. Okay, so to minimize this, what we need to do is take the derivative. Okay, so could I multiply everything by x here and get a quadratic? Sure, let's not. We don't need to. When I take the derivative, I'm going to get rid of this guy anyway, right? So let me just double check this. Both negative, yes. Okay, but I am worried about a negative. Nope, it's going to become positive. So here we go. Derivative. So that's going to become negative, positive 360 x squared minus 3 equals 0. Okay, we want to set it equal to 0. I'm going to move the 3 over to the other side. I'm going to cross multiply. So now we got 3x squared equals 360 divided by 3. That's 120. Take the square root of 120. Technically it should be positive and negative, but we're not going to care about the negative version because x should not be negative. So we got the square root of 120, and let's see, 120 is 12 times 10, so that's 2 times 6, that's 4 times 3, it's 2 times 5, so really that is x equals 2 radical 30. Yep, 2 radical 30, so that's it. 2 radical 30, which means that y has to equal 180 divided by 2 radical 30. Okay, so that's good. 2 radical 30 by 180. Well, you know what? We can divide by 2. That ain't so bad. I don't like leaving those marks there. Try that again. I don't like those marks. 90 over radical 30. Okay. That is not what the answer key says, so I'm worried about something. Is it? We got 2 radical 30. Okay, let me pause it real quick. Okay, this is right. This is completely right. It's just that they did they reduce this so that it looks like 90 radical 30 over 30, so then that 3. So I saw that 3 radical 30 and thought that we had done something wrong. But nope, this is 100%, so that's good.